Hello everyone, I welcome you all again to second part of lecture 5 in electromagnetic induction. I am Sameer Lavankar. So let's begin our discussion again. So in the last lecture we were talking about inductance. In inductance we talked about the concept of mutual inductance. A small problem was being dealt in which R1 was very less than R2. A small discussion is still left. We will first complete the complete discussion on that problem and then we will move on to self inductance. So just to reiterate you what is mutual inductance here. So when two long coaxial solenoids were being used, each of length L, and the value of L is very greater than R, then this concept of mutual inductance is possible, and hence this formula is to be remembered that M12 is equal to mu naught N1N2 pi R1 square L. If for the reverse case also it is the formula is same. So M21 is equal to mu naught N1N2 pi R1 square L. Just to reiterate to you again that how to write or what is the denotation here. So the number written on the right is with respect to, and the number written on the left is the value of the mutual inductance we are talking about. So here we are talking about the mutual inductance in S2 with respect to solenoid S1. In this we are talking about the mutual inductance with respect to solenoid S2 of what? Of solenoid S1. So this is a small concept I just reiterated to you. Moving on, if the medium is air, then the value of mu r is 1. But if the value of the medium, sorry, not the value, if the surrounding is changed, it is not air, then the value of mu r, that is coefficient of relative permeability, gets changed, and for finding out the mutual inductance we just multiplied the complete formula we calculated in the last slide by mu r. So after this a problem was being dealt with in which the value of mutual inductance we found was mu naught pi R1 square upon 2 R2. A small discussion is left here, so please focus now. So in the experiment 3, what is the experiment 3? Here experiment 3 is in the initial slides of electromagnetic induction we talked about the experiments of Faraday and Henry. In the experiments of Faraday and Henry, the third experiment dealt with the use of two coils, namely C1 and C2. The coil C2 had a tapping key K. What is a tapping key? A tapping key is denoted like this, that when you tap it, the circuit gets complete, so the circuit gets closed and hence the current flows through the complete circuit. So tapping key is denoted by K value here. This is the denotation when we make an electric circuit. This is tapping key K. So this was the experiment. So now in the experiment 3, EMF is induced in coil C1. EMF was induced in coil this EMF. EMF is nothing but electromotive force. It is nothing but voltage value. What is voltage value? Voltage is the potential difference across the coils. So wherever there was any change, I will iterate again. In the experiment 3, EMF is induced in coil C1 wherever there was any change in current through coil C2. So due to this a current was induced in coil C1. Let phi 1 be the flux through coil C1. So let phi 1 be the flux here. It is quite evident that the value of 1 denotes coil C1 here. If anything is talked about coil C2, then it will be denoted by 2 number in the subscript. So now let phi 1 be the flux through coil C1, say N1 turns. So N1 is the number of turns of that coil C1. When current in coil C2 is I2, so the current passing through this coil is I2 here. Current is denoted or calculated in ampere values. So now we have N1 phi 1. Please make sure that N1 phi 1 is called as flux linkage. So just to reiterate the concept of flux linkage again. So flux linkage is nothing but N into phi. If the value of flux linkage has to be calculated in coil C1, then it will be N1 into phi 1. What is N1 here? N1 is the number of turns in coil C1. What is phi 1 here? Phi 1 is the magnetic flux passing through or magnetic flux which is involved in, which is going through in coil C1. if we need to calculate the flux linkage in coil C2, it is nothing but N2 into phi 2. What is N2 here? N2 is the number of turns in coil C2. What is phi 2 here? Phi 2 is the magnetic flux through coil C2. So flux linkage is nothing but N1 phi 1 here for coil C1. So we calculated this value when we were discussing about the concept of magnetic induction, that N1 phi 1 is directly proportional to current in I2. So if we remove the proportionality sign, then it is for equality sign we calculate by multiplying the current with a value m, which is called as induction. So induction can be of two types, it is either self or mutual. Because there are two things involved, the inductance is not due to self, that is why it is mutual, because two things are being involved here, that is why it is mutual inductance and hence denoted by m value. So we have N1 phi 1 is equal to MI2 for currents varying with time. So if the currents are varying with time, just d by dt, differentiating the complete equation. Let me denote this equation by value of 1. So for currents varying with time, dN1 phi 1 upon dt is equal to dMI2 by dt. We already know from this concept here, which was Faraday's law of induction. The formulas are here for your quick reference on the right of the slides. So d n phi by dt is nothing but epsilon value. So because flux linkage is in flux linkage is in coil C1, therefore the denotation or the EMF induced is in coil C1. If the flux linkage was of coil C2, then the EMF induced would have been of coil 2. So please make sure, please think of these subscripts also while calculating the problems, while understanding the principles involved in electromagnetic induction. So moving on, so epsilon 1 is nothing but negative of d n phi 1 by dt. We already know this concept from Faraday's law of induction here. Therefore epsilon 1 is nothing but minus m di2 by dt. So this is nothing but minus epsilon 1 is equal to d by dt of m into I2. So the value of negative sign has been put towards the right hand side, so it becomes minus d by dt mi2. So epsilon 1 is equal to minus m di2 by dt. So a new relation, we found out a new relation here, that how induction of current happens, or how induction is a function of the current passing through another coil. Either way can also happen. Let us say we are passing the current through a battery in coil 1, then the current will be induced in coil 2. So that time epsilon 2 will be a function of current in I1. So this is a new concept we found out by simple differentiation and the concept of mutual inductance. So please remember this new formula again, that epsilon 1 is nothing but, or epsilon not by epsilon, we remember it like epsilon in something is a function of current in another thing. Let us say this is something and this is another thing. If we are denoting mathematically, then if we are writing here 1, then it will be 2 here. If we are writing 2 here, then it will be 1 here. So moving on to the last line here, it shows that varying current in a coil can induce EMF in a neighboring coil. Varying current. So if the current is varied, let us say current I2 is not constant with time, that is d by dt of I2. What does I2 mean? Current passing through coil 2 is not 0. If it is not 0, that means current I2 changes with time. Let us say at t is equal to 0, the value of current was 5 amperes. At t is equal to, let us say 2 seconds, the value of current is, let us say 7 amperes. That means there is a variation with time. So this is the only concept being talked here, that if it shows that the varying current in a coil can induce EMF in a neighboring coil as in not the same coil we are talking about, a different coil another than the coil in which the current is passing through. The magnitude of the induced EMF depends upon the rate of change as in d by dt, rate of change of current and mutual inductance of the two coils. So, what do we get, that if the current is varying through a coil, then in the neighboring coil the EMF induced is a function of mutual inductance. Let me denote mutual inductance by M here, and the value of current passing through. If the current passing through, if you are talking about 1, then it will be 2. If you are talking about 2, then it will be the value will be function of again M and I1. If the case is also reversed, then the complete concept is also 2 at that time. So, this is the final discussion I need to talk about here. So, please remember this formula also, that epsilon 1 is equal to minus M di2 by dt. So, now mutual inductance concept has been completed. Let us move on to self inductance. By the name of self inductance, what does it imply? It implies that if the inductance in any coil is due to current produced in that coil, then the inductance will be self, and hence the concept is being in line with the words written here. So, let us move on to the definition of self inductance. Just for a quick reference, the formulas are updated here simultaneously. So, please focus here again for self inductance part. So, in the previous subsection refers to the value of mutual inductance and stuff. We considered the flux in one solenoid has been depicted by S1 and S2 in the last mutual inductance concept. So, we considered the flux. What is flux here? Flux depicts magnetic flux value, we denote it by phi b. So, we considered the flux in one solenoid due to the current in another. So, if we are talking about the current in I2, then the mutual inductance has been talked in solenoid S1. If you are talking about the current produced in I1, then the solenoid we are talking about is S2. So, in the previous subsection we considered the flux in one solenoid due to the current in the other. It is also possible that EMF is induced. What is EMF value? EMF is epsilon value. The last concept, the last discussion we talked about in mutual inductance, what? That the EMF produced is a function of mutual inductance and the current passing through the another neighboring coil. If you are talking about 1, then it is 2. If we are talking about current in 1, then it is the EMF produces in 2. So, it is also possible that EMF is induced in a single isolated coil due to the change of flux to the coil by means of varying the current to the same coil. So, what is the concept being talked here is that if there is no neighboring coil, if this is the only coil, let me draw it carefully. If this is the only coil we are talking about, let us say the current has been passed through this like this. Let us say this is I only, there is no need of denotation here because there is no two coils we are talking about. So, the concept in this line is that if the current can be induced in the neighboring coil due to current passing in the neighboring coil, then can this thing be happened that the current is passing through, let us say, coil C, and EMF is induced due to the variation or the time rate of change of that current in the same coil. So, if the same coil is being talked about again and again, that means a concept of self inductance is being talked here. You will understand the concept when I will explain to you more clearly in the subsequent slides, but for now let me explain it like this only, that anything which is happening here is nothing but in a single coil. If the current has been passed through a battery or some another stuff, then due to the change in current with time, there is an EMF induced in the same coil. If the same coil is being talked about, then it is the concept of self inductance. So, it is also possible that EMF is induced in a single isolated coil due to the change of flux through the coil by means of varying the current through the same coil. This phenomena is called self induction. So, just iterating the stuff, just writing the stuff here, and this phenomena is called self induction. In this case, flux linkage. What is flux linkage? Flux linkage is nothing but N into phi. Flux linkage through a coil of N turns is proportional to the current through the coil and is expressed as. So, here everything is directly proportional to the same coil only. So, N1 phi 1 is directly proportional to I. Even if we do not write the subscripts here, it is nothing but N into phi is directly proportional to I. So, that thing is only written here. N phi is directly proportional to I. If we remove the if we remove the proportionality concept, then it is N phi b is equal to capital L multiplied by I. What is L here? First we were writing by M. What was M? M was mutual inductance. What is L? L is self inductance. So, denotion of self inductance is by the letter capital L, where constant of proportionality L is called self inductance of the coil. It is also called as coefficient of self inductance of the coil. When the current is varied, the flux linked with the coil also changes. When the current is varied, as in if with time the current is varied, that is di by dt is not 0, is not 0. When the current is varied, the flux linked, flux is phi value. The flux linked with the coil also changes, and hence an EMF is induced. What is EMF value? EMF is nothing but dn phi by dt in negative sign. So, if the flux is changed, then EMF is also induced. This is the only concept being talked about in this line, in this line. So, now using equation, EMF induced is given by epsilon is equal to minus n phi b by dt. This is the formula we are talking about here, is nothing but value of n phi has been changed with L di by dt. As the value of L is constant, as L is constant, hence epsilon is nothing but minus d n phi b by dt, which is equal to minus L di by dt. So, EMF induced formula is also being talked about here. So, now in this present lecture we talked about a little discussion on how the EMF is induced due to the changing current, due to the time rate of change of current passing through a neighboring coil, and it was a function of mutual inductance and the current passing through that coil. So, either it can be epsilon 1 is a function of M and I 2, or epsilon 2 is a function of M and I 1. Why value of M is constant? Because we already discussed that M 1 2 is equal to M 2 1. So, this was the first concept being talked in this lecture, and the second concept we talked about was the self inductance concept. What does self inductance talked about is that if the current passing through a single coil induces magnetic fields or induces EMF in the same coil, then this concept is nothing but self inductance. So, hence to conclude this part of the lecture, we already talked with introduction, experiments of Faraday and Henry, magnetic flux, that is phi b value. Faraday's law of induction is nothing but mutual inductance, Faraday's law of induction is nothing but the value of EMF produced, Lenz's law and conservation of energy, motional electromotive force, and now we were talking about the value of self inductance. When the concept of self inductance will be completed, problems will be dealt with, and finally we will go to the AC generator concept, a very good AC generator concept which involves complete application of all the things we already talked about in electromagnetic induction. So, for now, thank you.